Well, okay. So if you were looking to see what a big, long, free response question might look like, consider this question from a previous final exam. So you've got a particle moving in the xy plane, and at any time, the position of the particle is given by x and y, where we know what dy dt is. And we don't have an equation for dx dt, but we have a graph of dx dt, and we know where the particle is at time equals 0. So we're supposed to figure out where the particle is at time is 1. We're supposed to find the acceleration of the vector when time is 5. So the acceleration vector of the particle when time is 5. We're supposed to find the slope of the tangent line to the path of the particle when time is 5, and then the total distance traveled between 0 and 4. Okay, well, we can do this. Okay, let's find the position of the particle at time equals 1. Well, we know what dy dt is, and we know what dx dt is, so we can get the position of the particle by anti-differentiating, we can integrate dx dt and dy dt. So the x position of the particle is wherever it was at time equals 0, right? Wherever it was at time equals 0, plus whatever the integral from 0 to 1 of dx dt is. Well, this is the area. This is the integral of dx dt. If it helps, this is a y value of 2. So this is a triangle of area 1, 21. The y coordinate of the position of the particle, well, the particle at time equals 0 is at 17. And if we integrate from 0 to 1 dy dt, we can get the y position of the particle. Dy dt is how the y position changes, the y coordinate of the position changes. We integrate that over the time interval we're looking for, and it takes us from what we know about to what we don't know about. Calculator does this for you. And so the particle's position at time equals 1 is 21 18.905. Well, what about acceleration vector? Well, the acceleration vector is the derivative of dx dt, dy dt. It's the derivative of dx dt and the derivative of dy dt at time equals 5. Well, it's x double prime of 5, y double prime of 5. Well, what's x double prime of 5? Well, here's time equals 5. X double prime is the slope of this line, which according to this graph is 2. What's y double prime of 5? Y double prime of 5 is the derivative of this at 5. And again, a calculator does this. And so we can have an acceleration vector when time is 5. Okay, well, what about a slope of a tangent line? Well, slopes of tangent lines are easy because dy dx is dy dt over dx dt. Dy dt is 1 plus the cosine of t squared, evaluated at 5. Dx dt at 5 appears to be 2. And a calculator can do this for us and give us the slope of the tangent line at t equals 5. Well then, how about total distance? Well, total distance, that's an arc length. Arc length is an integral from 0 to 4 of the square root of uh, dx dt squared plus dy dt squared. dt. Well, that's a little bit of a problem because dx dt comes in two pieces. But what's good for us is that for one of those big long pieces, dx dt is just 0. So let's break this up. Let's look at things from 0 to 1, and then let's look at things from 1 to 4. From 1 to 4, the dx dt is 0, so we're just integrating dy dt. And a calculator can do that. From 0 to 1, we're integrating this thing. What's dx dt? Well, that's a line. That's the line y equals negative 2x plus 2. Sorry, negative 2t plus 2. So your calculator can do this. It can integrate from 0 to 1, 2 minus 2t squared plus 1 plus cosine t squared squared dt plus the integral from 1 to 4 of dy dt dt. The calculator can do all of that and leave you with a numerical answer. So what are the things that are important for you to see in a question like this? It is important for you to know the connection between position and velocity. So in this case, you were given information about velocity and you had to work your way backward to position. You could just as easily have been given information about position and had to come up with information about velocity. That could be just as easy. You have to know that acceleration is a vector and that it comes by taking the derivative of the x component of velocity and then the derivative of the y component of velocity. You have to know that a slope of a tangent line is dy dt over dx dt. And you have to know that total distance traveled is an arc length. And if you know those things, you are in very good shape. And all of the practice questions that you'll be seeing in Canvas will make a lot more sense.